This isn't our plan. Simply, we already done OLED 1 point. With that material structures, we already go in a mass productions. Simply said, brightness 800 and lifetime more than 10,000 hours, that is automotive specification minimum requirement. You are not cheating that spec because it is kind of in a trade-off. If we lower down the brightness, we can extend the lifetime. But we have to keep the lifetime because that is have to be in use more than 10 years. That is the industry. So if display is seen outside, outdoors, the bright is not bright enough. We cannot see the exact information. That's why bright have to be more than 800. Compare with the other application like in the mobile phone. Their lifetime more than 2,000 only. Brightness is 500 to 600 nit. If we increase the brightness, lifetime will be decreased.
Why we have to use LTPS? Why we have been used LTPS? Why we have to use the metal oxide? LTPS, we cannot make a better transit anymore because we have to make a better transit with polysilicon. We have to increase grain size. When we increase grain size, we cannot control the uniformity of grain size in polysilicon. So there is the limitation to make a better transistor with LTPS. But metal oxide case, there is no limitation.
Because of increasing BOM cost, I believe Apple will raise the prices for iPhone 14, all of the models. And the last year model plus $50 to $100. And then this could be impacting more or less on demand. So I'm a little bit more conservative for the build. But maybe I will be wrong. They will keep strong production, like maybe 90 or even 100 million. But in that case, I think we should carefully watch the end demand. And then if there's something wrong on the demand side, I think they will be slashing the production significantly in the first quarter 2023. So anyhow, we should watch carefully the pricing strategy as well as the end demand impacted by its pricing. And then,
as Apple decided to use OLED for iPad from 2024, Chinese panel makers are also rapidly responding to Apple's move. BOE B12 Phase 3 is planning an RGB standard line configuration, and Apple's iPad is the target. B16 is planned to be established in Chengdu as an 8.6G Haupt RGB tandem certificate line of oxide TFT for IT. Tiama plans to configure the Sherman Phase 2 as an RGB tandem line. The review is starting from the first half of 2022, and mid-size models such as auto and tablet PC are targeted. The 8.5G RGB random channel line is being considered for IT, and Wuhan, Shenzhen, and Hebei are candidated place.
So also we think about how IT panels, so because it's also competition for us when they use oxide. So from oxide, from TV, you can scale down. Going to IT panel sounds easy. It is more or less easy. So it's always mentioned less mask layers. So you need less evaporation steps, make it cheaper. Yeah. So compared to LTPS or LTPO, where you need more TFT layers to make the structure. So the invest cost could be less. It's pointed out that all the equipment for Gen.8 0.5 oxide more or less is available today. So the sizes can be made. They can be made for TV, but they cannot be made for smaller TFTs today. But
fine metal mask. So what we did is we have used ultra short pulse laser, a femtosecond laser to micro 5070, and then we have a special optic which divides the optics in like the 3x3 or 4x4 spots, and the spots are not circles, they are squares. So we have a special know-how developed for our customers to make any beam shape he would like. There are almost very little limits. So we can make squares, we can make even hearts if you want. And this is done by holographic optics. And this holographic optics we don't buy from a supplier. We make this the calculation, the testing, as well as the production by ourselves in the lab, in our manufacturing. In this case, we had a 3x3 matrix or 4x4 matrix with holes, with squares, and then we used this for ablation for these fine metal masks just to make these, let's say, curved or shaped holes, square holes. And this
Okay, so we have been working on OLED micro display for long years for electrical viewfinder of the camera and head-mount display. So our OLED micro display consists of white OLED plus color filter on CMOS backplane. So we first made a market introduction in 2011 and have been leading the OLED micro display industry. So because of its high image quality and small form factor, I think OLED micro display is one of the best displays for near-to-eye application.
We are designing our pixel structure for 30,000 PPI as well as 4,000. We are going to adopt a diamond structure for our 4,000 PPI structure. And we are designing our pixel in such a way that we can maximize the aperture ratio of our display. And also, we are thinking about new structures to improve the efficiency. It's light extraction efficiency of the OLED structure. And we have been working with Atri for light efficiency improvement work.
I came up with shadow-free idea, which is parallel molecular beam evaporation deposition technology. As we saw earlier, in the point source evaporation process, the point source or linear source, they are same, is going to be emitting the spreading molecular beam to deposits showing some of the shadowing area. However, in my plane source evaporation technology, the donor film on the metal plate will be re-evaporated in the surface normal direction to be deposited, giving almost zero shadowing area.